All right, so I hope you guys saw that I posted on the A&P website information and the link to the night at the library, which is, I think, February 21st. They have prizes, they have food. I believe Sherry is going to ask the pro section students to also be there because they're looking for people to kind of give you guys advice and help and study tips and things like that. And so if you show up, there'll actually be like some people that can talk to you about A&P 227 and 228 and pro section, if that's something that you would be interested in. So to be a pro section student, I think all of you guys have gotten to meet a couple of the mentors in lab, yes? So you just have to have done 227, done a pretty good job. You don't have to get an A or something like that, but to be interested, you didn't just hack apart your cat when we get to that. So that you have some skill and that especially any students that are interested in getting into the healthcare field, whether it's nursing, physical therapy, any of that kind of stuff, it's great to get in there. And we've had students when we've had an open house where we bring both cadavers out and we allow people around campus, other students, other faculty. It does have to be adults, so 18 and over. We'd make an exception for you. It's okay. But we've had younger people there. Sometimes people want to bring like their young kids, and we can't make exceptions and stuff. And people aren't always prepared to see cadavers. So anyway, we bring that out so that people can come and see. I don't remember what the point of what I was saying. Darn it. Oh, well, okay. So pro section is awesome. Oh, I know what it was. So we had some of the students that had been through pro section and already got into their program that they were looking into. I believe they were in the PTA program, so PT assistant, and they were super excited to come back and review some of the things because by the time you get into your programs, you're learning everything more from landmarks on the outside of the body and trying to figure out where it should be on the inside. And so you kind of forget what you learn in pro section or A&P sometimes. And they were super excited to come in and get to play with some things that they were currently talking about, like in the glute region and the muscles of the thigh and things like that. So it was pretty cool. That was my point. So I knew it would come to me. All right. So anyway, I hope you guys will go to the library night. You might as well. They have prizes and food, and maybe you'll pick up some other study tips, and maybe it'll make more sense to you than just me telling you guys should do some of these things. But we started working on epithelial tissue, so the epithelium. Think of this as like the tip of the iceberg. I'm giving you just a little information, and we will go into more detail. So some of the things that you have looked at in lab, you did look at more detail on the slides than what I'm about to talk about. That's okay, because it's like feeding you a little bit and we come back to it, feeding you a little bit and we come back to it. So hopefully that repetition also makes it easier for you to remember this stuff by the time we get to exam 2. So we went ahead, we talked about how we have 2 types, coverings and linings or glandular. And then we had special characteristics. So we said epithelial tissue is very cellularized, or it has a lot of cellularity. That just means it has tons of cells, right? Because as we look at some of the other tissue like CT and stuff, you're going to see that it's not so cellular-like, okay? So we talked about an apical surface and the basal surface, and that's going to come back in a second. We talked about how we classify it with squamous being tile-like or flat scale-like. Cuboidal is kind of like the poofy square balloon. Columnar looks like a column, right? So that makes sense. And then we were just starting to talk about classifications by the number of layers. So you guys already saw most of this also in lab, so hopefully this reminds you of that. But simple means what? 1 layer. So, and we also said that simple squamous will line the capillaries. It'll line the small air sacs of the lungs, like the alveoli. Lining of the glomerulus or the kidney, which is the picture that we, oh, okay, come back. Never mind. Which was the picture we had here. This whole thing here was the glomerulus. I'm drawing that circle a little short. And then we said the squamous, simple squamous, was all here lining that. So there's a little space in between the glomerulus and the lining of the area surrounding the glomerulus. And also we have lining of the blood vessels. And we gave that a special name, which again we'll come back to in the future, but we call that endothelium. Endo is within, thelium, epithelium, so it kind of reminds you. And you guys may not remember all of these details sometimes when we get into 228, but the funny thing is we get into 228 and we tell you all the same stuff again, but faster because you've already learned it once, and then we build on that even more. So it's not like we teach it once and then you never see it again. You're going to see it again and again in 227 and definitely in 228. We went on to the next part. Maybe we didn't talk yet about simple cuboidal, right? So simple meaning one layer of cuboid, so cuboidal shaped cells. So simple cuboidal, and you'll see also with simple columnar, single layer of column-like cells are both good for secretion and absorption. Secretion means the cell is putting something out. Absorption means it's allowing stuff to come into the cell. Now, it doesn't necessarily mean that just the apical cell is getting what's being absorbed, right? Maybe we're going to absorb it and bring it to another part of the body. But for the time being, I just want you guys to understand secretion and absorption are good for simple cuboidal, simple columnar. Okay? So if we go back to simple cuboidal and we have secretion, an example would be glands and walls of the ducts. So you'll see a duct wall will have one single layer of the cuboidal. So you can tell the difference between the simple cuboidal and simple squamous because look how you could imagine there's a dotted line here. So this is kind of a really fat cuboid cell right there. Here's another one. Here's another one. And it's single layer because there's not another one right behind it or in front of it. And this space here, do you guys want to give it a name? A lumen, L for lumen. So a lumen is an opening or a space, right? And it could be, you know, if you have the lining of the endothelium, then the tube of the blood vessel would be the lumen, right? So if we were doing absorption, we would notice that in the kidney tubules is where a lot of absorption is going on. So, and then if we look at simple columnar, same thing, secretion and absorption, and we see simple columnar especially in the digestive tract, okay? Or so especially like small intestine more than the large. But so you have secretion because you might have to put something out, but also absorption because what do we want to do with all these nutrients we just started breaking down in the stomach and small intestine? We need to take it in, right? We break it down, but we need to get it into our cells, get the nutrients to feed us. So let's see. And also in simple columnar, this would be the lumen of here. And you can imagine right here is a columnar cell. Here's a columnar cell. And again, there's not another columnar cell behind it. You have the lumen on the apical surface of it. So that's why it's simple, okay? And what else do I want to tell you? All three of these histology slides, this one, and this one, for simple, squamous, cuboidal, and columnar, are all from the kidney. But they all look a little different, right? So depending on where you're looking at the kidney would depend on whether you're seeing a simple squamous area or a simple cuboidal area. So I just wanted to point that out, that within an organ you may have many different, not just tissues like CT and kidney cells or something like that, but you also will see different shapes or stacking, so the various classifications within the same tissue. And let's see. Oh, another thing to point out would be, what would we call this area right here, or this area right here? What would you call that area? The basal area, or the basement membrane, which is the basal area would be against that. And this side here would be what side of it? The apical side of it. Yeah. So same thing here. This would be the basilar side of this one, right? And this would be the apical side of that cell. Okay, so even with a simple layer, you still have an apical side towards the free space area or the air side or something like that, versus the basal area, which would be towards the basement membrane side. Okay, and characteristics unique. I'm having trouble talking today. See, I can't even say today. Characteristics unique to columnar epithelium. So now we're just looking at just the columnar cells. what is special about these guys? So we have three that we want to look at. We want to look at goblet cells, microvilli, and cilia. And did you guys take the time to find some goblet cells in lab, whether you did it virtual or whether in Connect or whether you did it with the microscopes? Now, when you first tried to look for it, it probably wasn't so obvious. You're going, I don't know what I'm looking for. This is crazy. Then once you started to realize what a goblet cell looked like, it was much easier to pick them out, even if the slide had different staining technique, so it looked slightly different. But once you found them, it was like, oh, that's a goblet cell. So this whole thing right here is a goblet cell. And here's another guy right next to him. And that guy's probably one there, but I wouldn't pick him because there's two other much better looking ones next to it, right? And here's another guy over here. And so do you guys know what goblet cells do? Do you remember? It produces mucus, which is for protection and lubrication of adjacent cells. Adjacent means next to. So it makes sense that where you see goblet cells, you're also noticing that you are keeping things moist and lubricated around the area. It also gives almost like a little mini slime area, if you will, to protect it. So that's nice. I know we all want to talk about slime, don't we? Let's see, what else? If we look at microvilli, you guys already know that microvilli are for increasing surface area, right? They're little finger-like projections sticking up. So they have cytoplasm within them, right? And microvilli were different than cilia. And why do we need in microvilli, what's the whole point of having increased surface area? It's for more absorption, right? And what did we say about columnar cells? Look, absorption, yay. Okay, so cilia, you guys learned before, only move things in one direction. And so they cock and then they push things along. And then it recocks the arm and pushes it along. So the cilia are more like hair-like substance. And it says it moves stuff along the apical surface. So that makes sense, right? And we said this might be moving, you know, if you get sick and you're producing tons more mucus than normal, you got to get that mucus up and out of there. You don't want it clogging up your lungs and not allowing things to get past that mucus so that you can absorb and that type of thing. So you're finding goblet cells. If you want to find them, you're going to look for columnar cells. If you find columnar cells and you go to certain areas of the body, you're definitely going to see tons of goblet cells, tons of them, okay? Microvilli, you're going to see, where did we say we saw them before? Do you guys remember? Maybe intestines would be a good area, good. Cilia, like the trachea, things like that. Okay. Let's see, what else? Goblet cells, you're going to find those also in the trachea and digestive tract. Also, you might find goblet cells with pseudo-stratified columnar cells. So if we talk about pseudo-stratified, pseudo means false or fake or faux. It says it looks like it's stratified, but it's not. So it's a single layer. That's why it's called pseudo-stratified. It looks like it's a multi-layered columnar set of cells, but it's a single layer. So I drew a little picture here. So here's my basement membrane. Here would be my apical surface, right? And they all touch the basement membrane, okay? So that's why you see that there's always like this cell, this cell, this cell, this cell. They're all touching your basement membrane. And the nuclei aren't, some cells, their nuclei are closer to the basement membrane. In pseudostratified, they're kind of some are a little higher, some a little lower. And that's what also gives it that pseudo look that you think it's stratified, because it kind of looks like there's multiple layers in there, but it's still a single layer of columnar cells. So the pseudostratified columnar epithelium always seems to be ciliated also. And we'll tend to find these guys in the trachea. Okay. And let's see what else. So that's about it for pseudostratified. And these would be one of those things, you know how I'm always telling you guys, hey, you could draw a quick picture on your exam so you don't forget which one is which or mix up what they look like. So it's super fast and easy to draw something that's what simple means. And now we're moving on to stratified. And you could draw a quick picture of pseudo-stratified so you don't forget it's not really stratified. It just pretends to look like that. So now if we talk about stratified epithelia, now that means two or more, okay? and 2 or more layers of cells named for the shape of the outer row. So what that means is, for example, if we look at stratified squamous, the surface or the apical side of it looks like it's squamous. That's why we're calling them squamous, stratified squamous. Whereas the deeper layer, those cells, if you look at the basement membrane of that layer, actually looks more cuboidal. And the reason why is because that cuboidal layer along the basement membrane, those are your newest, youngest cells, your baby cells. Those baby cells are little chunky monkeys, right? They're fresh, they're young. You want chubby little babies, right? And as they get to the surface, so that layer then, a new basal cell will grow. You'll divide, you'll go through mitosis. You'll get a new one, and the one that was there on the basement membrane now gets pushed up closer to the surface. You make another one, it gets pushed up to the surface. So as you're on your basement membrane and you have these cells that kind of look a little more cuboidal, a little more fat and poofy, right? And then there's another layer on top of there, and they're really close. So just pretend like I drew these like really well stacked like in this picture. And then as we're getting more apical, okay, we're going to start flattening out more and becoming more squamous-like. They are, what did we say about epithelial tissue, by the way, with regards to vascularity? Does it have a lot of vascularity or no vascularity? It is poorly vascular. It's no vascular, actually, not poorly. No vascularity. Avascular. A means not vascular, right? There is no blood supply there. The blood supply is down here past the basement membrane. So the nutrients, because your blood is what's giving you your oxygen and traveling around some of the nutrients, has to diffuse up to this young layer here and make its way up. And what do you think happens the further away it gets from its nutrient source? It's decreasing. Not as much is going to get through layer after layer after layer. Your outer layer of cells is basically dead, okay? And that's why it's okay for it to slough off, and it doesn't hurt. And you know, anybody ever see like the movie Gattaca? Long time ago, yeah. Right? So that movie was based on, and maybe you guys should go check it out sometime, especially after talking about DNA. Gattaca, if you guys notice the letters of DNA, G-A-T-T or T-A-C-A, I can't remember how many T's they stuck in there, but they were using the DNA code for the name of the movie. And one of the things the guy did in the movie, because it was like a futuristic society where you couldn't be what you wanted to be because they tested you ahead of time and said, oh, you're going to die young, so you can't be an astronaut or you can't be a this. You're not going to be smart enough to be this. Like they predetermined what you are from being a kid. And this guy didn't want to do that, bless you. So in the movie, he finds a way to change things about himself, but he's got to slough off his own DNA throughout the whole movie. So he's always brushing off his DNA. Because if your DNA dropped somewhere else, they would know who he was. So he had like urine, he had hair samples with him that he could drop off to be this other guy that he was pretending to be, who used to be like this Olympian, you know, Superman kind of guy type of thing. So it was funny. If you watch it again, or you watched it a long time ago, watch it again, because it's kind of interesting to see, and it has everything to do with the DNA stuff, and he gets found out eventually. So anyway, this apical surface looks more squamous because it's further out towards the top. The basement is the chubby little baby cells, and as you do cell replication, and then you're going to make this cell become now 2 cells, right, 2 identical cells, and then the basement membrane pushes up, and then a new cell is going to be there, or 2 new cells, and it continues to push up, and then eventually that sloughs off on the most apical surface, and the further away you get, the less cytoplasm there is, the more squamous it ends up looking. And again, we're naming stratified epithelia based on the apical surface. So, all right. If anything, if you guys remember the movie Gattaca and do better on the exam, more power to you, right? Okay, so it covers areas of high abrasion. That makes sense, right? So we're covering our skin. We bang into everything, right? So this makes sense that it would be on our skin there. And I mentioned before, like in your mouth, right? When you chew food, you guys, sometimes you eat something and it roughens up the inside of your mouth, and it seems to heal fairly quickly in there. You bite your own tongue, you got to heal this stuff, right? So it's the most widespread, so most common of our stratified epithelium. And it's going to be from your skin and into the openings from the skin. So an opening from the skin would mean, like you could think of your tube from coming from your mouth down the esophagus and stomach, small intestine, large intestine, and then out the anus as one big, long, open tube. It's not totally open because we have sphincters and stuff, but that's an opening to the outside world. Are you not putting things from the outside world into that area, processing it through your body, and then putting it back out? Okay, so think of that tubing as kind of like your sewer system, and it's open to the outside world. So you need stratified squamous epithelium in these areas, okay? All right, so we'll talk more about epithelium specifically when we get into like, when we talk about the integumentary system in a little bit, but that's going to be another lecture or two out. So just hitting the tip of the iceberg right now. We also have keratinized versus non-keratinized. So keratinized contains keratin, so that makes that easy, right? And so with keratin, what else do I want to tell you? Told you that, shedding, yep. All right. And so keratin, which is basically a waterproofing protein, okay? It's found in our skin, and it's not really waterproof. It's more water resistant, because if you get in a bathtub or go swim in the lake, remember you're going to absorb water in between the cells when we talked about like the things that link our cells together to keep them together, like desmosomes and do you guys remember some of the other ones? Gap junctions and things like that. So remember we said water could get between, but it doesn't go into the cell, but it makes you look all pruny, right? And then the water will go back out. You'll dehydrate it out of you. It'll evaporate off, and then you'll start to look normal again, have a normal looking fingerprint, that kind of thing. So it's not really waterproofing. It's more like water resistant, okay? And so it protects us not so much from water trying to get in us, but from our water leaving. So this protects us from dehydration. So protects from dehydration. Okay. And so it would make sense that keratinized should be on the outer skin type layer, right? Do you think we need to be keratinized in your mouth? No. So non-keratinized does not contain keratin, and that would include like the stratified squamous epithelium of the tongue, the mouth, the pharynx, meaning in the throat. So we don't need keratin there. Why do you think we do not need keratin? Because it's moist. Some people don't like that word, moist. We're moist in here, right? So are we worried about, I mean, if you had your mouth open and you're a mouth breather and you might get dehydrated because you're breathing and letting all of your liquid out, you know, dehydrate off of you. But typically, you close your mouth and you're going to stay moist in here, right? And hopefully you're drinking water throughout the day and keeping hydrated. But anyway, that's why you don't need keratin there, because we're moist in here. We're not worried about losing that fluid, okay? So these areas have moisture. I knew somebody that couldn't stand the word moist. It drove them nuts. They're like, don't say it. So it has moisture, which protects the cells. The moisture does. That's an S. All right, so no need for keratin there. All right. What about your esophagus? Would that fit in this category? Yeah, it would. Yeah. So esophagus also has stratified squamous epithelium. So just kind of think about what is the purpose of this area, the function of the cells. Don't hesitate to go back to your lab manual or, you know, your histology section, and you can add a few details, because technically when you guys were going through the histology mini exercises, it was trying to get you guys to understand why the cells look the way they did and were in certain tissues, so their function helped you understand why they were where they were. So now that you get a better understanding now, you can go back and things might click even better for you on what you were doing with your histology atlas. Then we have stratified cuboidal. This is rare, so we don't see it a whole lot. It's only 2 layers deep on stratified cuboidal. And an example would be the ducts of our sweat glands. They're not easy to find. So it's just kind of, you know, So just know ducts of your sweat gland. So this would be possibly a duct of a sweat gland. So this would be the basilar area. This would be the apical surface. And you have, 1, 2 cuboidal cells, but it's not maybe the easiest to find or to see. But you understand, if somebody described it to you, you'd go, oh, yeah, 2 layers, so it's got to be stratified, cube-shaped, cuboidal, done, right? Where would I find it? I'm going to look for ducts of a sweat gland. Also, stratified columnar is also rare. So this would also be a few rows at most. You're not going to see a whole lot of stratified columnar. Okay, so this would typically be found at transitional areas. So for example, male urethra would be where you would find this. And again, the funny thing is, so the basal layer of these cells look cuboidal to me. So here is the basement membrane. Here would be what sort of looks like a cuboid cell, and then here would be like the columnar cell. So, and again, it's named because of the apical surface. This is the apical surface. Here's your lumen. So this area is your stratified cuboidal layer. I'm just walling off a whole bunch of them right there, but just to give you an idea. So again, rare, kind of just see it in one area apparently. Now another form of stratified epithelium is transitional epithelium. So this forms the lining of, for example, the urinary tract. And so this is going from the urethra up to the bladder. I just put the example of bladder because you guys have sometimes a better understanding of the bladder itself. So what happens when urine fills up the bladder? It's going to stretch because this is, without urine in it, it's kind of like shrunk up like a little firm ball. When urine is being produced and coming down from the kidneys, down the ureters into the bladder starts to fill up. So those cells will look transitional because when it's squished down tight, it'll look different than when it's filled up with urine. Okay? And so that's transitional. So also after it's filled up and now you void the bladder, meaning you let the urine out, usually it could be out in the forest, but could be, on the toilet, wherever, swimming pool, lake, I don't know. Anyway, so you let the urine out. You let the urine out, and then you don't want this big floppy thing inside of you, so it shrinks back down. So remember when we said, we need stretch and recoil. We need it to shrink back down. So that's the idea with the bladder. So the surface layer is more dome-shaped if it's not stretched out. So think of it as being a little more poofy when urine isn't in there pushing against it and flattening it out a little bit. So you can see that there are many layers. So this would be the basement layer area here. And you can see that there are, multiple layers of cells if we drew, circled some out and stuff, right? And then these guys look a little different than what those guys did down there. So that is surface layer dome-shaped if it's not stretched. The apical cells can possibly be binucleate, meaning bi is 2, nucleate, meaning they may have 2 nuclei, or nucleuses, nuclei is the plural actually. So they might have 2, they usually have 1, just to give you an idea. Now here is another thing that you could draw, for example, recreate during an exam that might help you. It's called an epithelial concept map. So concept map is just, you have the big title of types of epithelia. And we just had 2 major categories that we first talked about. You had simple or you had stratified. Simple meant 1 layer, stratified meant 2 layers. So now if we just look at the simple side, you have simple squamous, simple cuboidal, simple columnar, and remember pseudo-stratified is really what? Simple, right? So you could draw those really quick, a little map just like this. It kind of looks like a family tree, right? This person married that person. They had these children here. So that might help you keep it straight where you write this out really quick before you read any questions on the exam. If we look at the stratified side, so this is the purple side, you've got stratified squamous, cuboidal, columnar, and transitional. And then under stratified squamous, you had one more subdivision, right? You had keratinized or non-keratinized. Did it have keratin in it or not? Right? So that's a really quick way of taking all that information that you just learned, sticking it in a shorthand and boom, you don't have to triple think it and go, but wait a minute, the question says this. Start second guessing yourself. And so that might help you guys. And I suggest writing it out. And you don't even have to make it ginormous like that, you know. Now if we go to, so we talked about the linings. Now we're going on to glandular, right? So the glandular epithelium, so this is single or multi-cell structures that secrete a product. And that product that's being secreted, we call it a secretion, okay? So these can be hormones. These could be sweat, sebum. It could be earwax. Another name for earwax is cerumen. So these are secretions that your body produces from glandular epithelium, okay? And we have different reasons why we should have these secretions, right? So briefly, I'm going to talk about endocrine glands because we really don't get into it a lot in this semester because we talk a lot about endocrine glands in 228. So just a brief little history, endocrine glands secrete directly into the bloodstream. They are ductless. So they don't need any duct to get their hormone, typically, is what's being made, right? So if we're producing hormones from the endocrine gland and it will get secreted directly into your bloodstream, the hormone will travel to its target organ or area that it needs to get to and cause the effect that that hormone was intended to cause. So again, we'll cover this way more in detail. We have a whole chapter on endocrine glands. Moving on, if it's not an endocrine gland, it must be an exocrine gland. An exocrine gland are the most common type, and these typically contain ducts. So just think endocrine, ductless, exocrine, ducts. So a duct means you have something that is going to secrete to a surface, and the surface could be an internal surface or external. So for example, sweat would be secreting something to the external surface of your body, and you'll see it on your skin, right? On the outside of your skin. Versus you could secrete something, for example, from the pancreas that is going to be a digestive enzyme. And so you're secreting it inside of the body to an area or a lumen to help break things down. The interesting thing, for example, about the pancreas is it has both endocrine and exocrine glands in function. So some things have both. Some things are only one. Some things are only the other. So some examples of exocrine glands would be sweat glands, glands that produce oil, salivary glands, and again, could be an internal or external surface that it's being delivered to. And what else do I want to tell you? Another name, because we'll get into more detail about this later, but another name for a sweat gland would be a sudoriferous gland. So think odor, sudor, you know, because sudor for Latin means odor. So you could just think sudoriferous, sweat, same thing. Oil could be from a sebaceous gland. So your hair, you'll have sebaceous glands in that area that produce oil to lubricate. And so some people might notice more oil production than others. If you wash your hair maybe too much, you might strip that oil off, and it's there for a reason. But you don't want to have super oily hair because that doesn't always look good either, right, in society, I guess. So if we then break down our exocrine glands, and we can have certain types, so can you see how you can make another concept map out of this? So we could have a unicellular, meaning a single cell gland. So I just told you that exocrine glands contain ducts, but there's always exceptions to the rule, and this is one exception. If it's a single cell, it doesn't have a duct, because a duct is like a series of cells that create a duct system. So unicellular does not have a duct. It's just the one little caveat that you have to know there. It is located at the surface. It empties its contents to the surface. And a great example is a goblet cell producing mucus to the surface of the intestinal tract, right? Or something. So goblet is a single cell producing the mucus. That's why it's a unicellular gland. Now, back to what is normal for exocrine glands, meaning many cells, and these guys are going to have ducts. You have multicellular, many cells, all possess three components. So it has a duct, it has acini, acini is the plural for acinus, Acini means a cluster of cells that create the secretory product, and it has supporting or supportive connective tissue. So meaning that it's surrounding the gland and can divide the gland internally into lobes or lobules. Lobules just mean mini lobes. So many little lobes or lobule sections, okay? Let's see. So that acini area, the cluster of cells, is usually going to be at the base of the gland. And we can classify these by the duct, the secretory unit, and or the mode of secretion. So now we can subdivide this. So we have multicellular, and if we call it a simple duct, simple means one. So it's one unbranched duct. So a single branch, no multi-branches. That makes sense. So a simple duct would be a single branch. So they're showing you here simple glands. So it means one. So one tubule here, right? There's no multi-branching going on there. And when they're talking about the branched part of it, not the secretory unit, okay, they're talking about the yellow color of those cells versus the more orangey color below, okay? So the yellow color of all of these is single. Can you guys see that? Single branch, unbranched. That would be a simple duct. Versus, if you look at the lower picture called the compound glands, this is where they're saying that it's a branched duct. So if you look here, you have all of this is yellow, yellow here, yellow there, yellow there, yellow, 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 yellow. So can you see how we're saying multi-branches now? That's why it's a compound duct system, okay? Whereas these guys, again, this was the yellow part, just like that. So then you can classify it by the secretory unit, and it could either be tubular shaped, which means the lumen has the same diameter as the duct. So the duct, makes sense that the duct is near the surface, right? So the duct here, okay, and can you see the tubule, the acinus part here, is about the same width as the unbranched single duct area, correct? Okay. So then if you have alveolar, well, what does alveolar sound like? Alveolar air sacs. And if you guys have seen alveoli before, they look like little grape clusters, so they're little roundy shapes. So that's this guy, more of a roundy shape, okay? So these are the secretory units, the orangey part. And then tubuloalveolar, what does that sound like to you? It's a combo shape of the tubule shape and the alveolar shape. And they're kind of trying to show you that it has a bit of a tubule shape here and then the alveolus. But you might have, you know, where it's more alveolar on some, and then you might have more tubular with a little alveolus at one end. And so it can vary, but it's just trying to tell you it has both structures to it. So you could have simple or compound on the duct part, which is near the surface. You could have tubular alveolar or tubuloalveolar, which are the secretory unit part, so that's deeper in. And then we can have modes of how we secrete it, we can classify it. So if it's a merocrine gland, it means that it's a vesicle that is being exocytosed. So they're talking about the cell itself. And remember how we said, like, we can make proteins from the rough endoplasmic reticulum, and then we send it by a vesicle to the Golgi apparatus. The Golgi apparatus folds and changes the shape and packages it pretty and sends it out by a vesicle, and it can either go somewhere else in the cell, or it could go to the membrane of the cell, the phospholipid bilayer, and exocytose it out, meaning the product can go out, right? So in that case, we were talking about a protein, but this could be about anything else that we're making in the body that we need to exocytose and get out. So that's an example would be a merocrine process. So the cell is not destroyed in the process, because when we exocytose something, we're just merging with the outer membrane and letting the contents go out, okay, to the extracellular side. And so merocrine is the most common way, and for example, sweat. So we're not destroying cells when we're sweating, okay? We're just allowing things to get out. Apocrine is part of the surface membrane pinches off with the secretory material. Okay, so it might need to change and repair, but again, we're not destroying something with this process. And for example, with the apocrine cells, this might have to do with the mammary glands, like with milk production, right? Or in your ear when you're producing cerumen, okay? The difference is, and so that was a pinching off, okay? So the surface membrane, it's kind of like when you make a vesicle to merge, whether you're doing exocytosis or you bring it in and pinch it and it comes off and goes into the cell with endocytosis. It's kind of like that idea, but you're not destroying anything when we do that. Holocrine glands, though, is the apical cell ruptures. What does rupture sound like to you? We've burst our cell. So we've ruined the cell. Once it's burst, that's not a good thing, right? In this case, it's a normal process, though. So the apical cell ruptures and becomes part of the product. So the dead cell parts can now go out with the product, okay? So what happens is you get a buildup of the production of your secretion, whatever it is that you've been making. It ends up filling up the lumen, right? So here's our lumen. So we're making and we're secreting something. It fills up the lumen area. Then it goes up the duct area. It fills that area up. And then it ends up getting released to the surface, right? And then you'll have cell death of those apical cells. And so, for example, this might be with our oil and or sebaceous glands, okay? So let me see if I can, what about acne? What would acne fall under? Would it be a merocrine, apocrine, or holocrine process? Acne. Take a guess. There's 3 choices. Holocrine, yes. That'd be like a holocrine process. So they're showing you down here with merocrine, you just have exocytosis. So they're just showing you these little dark gray or blue, I'm not sure what color dots these are being produced by the, what are the cells that we said are down here? The acini, right? The secretory unit, right? I'll put S for secretory part. So it's exocytosing from inside of the cell to the outside, spilling its contents out, and then that gets out. So this would be like your salivary, your sweat, that kind of stuff. Apocrine, we pinch off part of the membrane. What's the membrane made out of? Phospholipid bilayer, all right? Yes, I'm glad you said that. And it's also, the secretory unit is what put it out there, and it goes up, the yellow part is your duct, and then it'll get out to the surface. So you have these little white dots there. So mammary, think the milk production, right? And then the holocrine, the last one there, we said we're actually destroying. So they're trying to show you here, here's one of those cells that's broken apart. So not only its product that it made, the secretion, but also the now dead burst apical cell is all getting put out. So sebaceous gland, acne, that kind of stuff. All right, so I suggest, make another chart of that kind of stuff to help you guys keep this straight and practice thinking about what are the different ways that I can classify these ducts and glands. Moving on, we're now going on to the connective tissue. All right, let's see. What else do I want to tell you? Yep, told you all of that. Did I write that all in there? Yes, okay. Ding, 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 connective. So, go back. The most common of all tissues, right? And it has all kinds of stuff associated with it. But if you notice, it's not a lot of cells. So it's not the cellularity that you have with epithelial tissue. So we had epithelial. Now we're talking about connective. Later we talked about muscular. And then after that we have nervous. Those are our 4 tissue types we're talking about. So we're on number 2, which is connective. And so not a lot of cellularity like the epithelial cells. There are cells there, but it's not like epithelium. So this picture, this cartoon, looks very different than the epithelial pictures you saw, yes? I hope so. All right, so common origin means they all arise from mesenchyme. What they're telling you there is that the parent cell, the cells that these guys originated from is mesenchyme, as in when you were an embryo. That's what they're talking about there. Vascularity, it will vary from avascular to richly vascular. So some CT is avascular. Some CT has tons of blood vessels running through it. And so that's why we put variable there. So it depends on which specific tissue you're talking about of CT will depend on how much vascularity it has. And then there's also extracellular matrix. So this is the bulk of the tissue. It's non-living material around the few cells that are within it. Okay, so let's see. So structural elements of CT, we have three main ones. We have ground substance, protein fibers, and the cells of CT. So if we talk about the ground substance, it's produced by CT cells. It fills the space between the cells. So your ground substance is all of this stuff in here. Ground substance. Okay? It's what everything else is kind of floating around in. It's the matrix. So this can be interstitial fluid, meaning it's between the cells, right? I didn't draw the X in a cell. I drew it between the few various cells that are in it. And then it's mostly made up of water, right? We're mostly made up of water. Makes sense. This has mostly water in it for ground substance. Okay, I'll take it. And it says adherent glycoprotein. So adherent, kind of think of like a stickiness, or this is making your glue essentially, right? So connective tissue glue, if you think of like glycoproteins, for example, glyco meant carb or sugar, and protein. So you are making it kind of like a jello-like substance, and some of it might be less solid and some might be more solid. So thicker jello-like to less jello-like finish, you know, maybe before it firms up. So that's what we're talking about on inherent glycoprotein. So it depends on the type of CT, depends on how solid-ish or semi-solid or less solid it is. And if we look at the protein fibers, the next part, protein fibers provide support. Well, that makes sense. So there are three types of fibers produced by fibroblasts, okay? So fibroblasts, fibro meaning fiber, blast means it's usually making something, actively doing stuff. So fibroblasts, they can make the collagen, the elastin or elastic fibers, or the reticular fibers. So these are the three protein fibers we're going to look at real quick. And I'm going to roll it up just a little bit. So on collagen, collagen is very tough. It's got like a cable-like or thick type of support to it. So it's cable-like. So think thick, strong, that kind of thing. It's unbranched. Okay. And it doesn't stretch well. Okay. So it doesn't stretch much. So it has a little stretch, but not a lot. And this forms 25% of our body's protein. So 25% of our body's protein. All right. So if you were to stretch it too much, what do you think would happen to these collagen fibers? They'd break, they'd tear, okay? And then they really don't help you out if you've torn them, okay? So there's no recoil to it. And for example, so we have a lot of collagen associated with our dermis. So under the epithelial layer, usually after the basement membrane, you have CT after that. So you should have collagen in that area as well. And when somebody either gains a lot of weight and then loses it, or if somebody is pregnant, they will tend to get what? Stretch marks. And those stretch marks are because the collagen fibers ripped. Okay, they got stretched too far. The growth happened too fast, whatever. And so then, you know, the body is coming back to shape if you end up losing the weight, or you, you know, have the baby. So now you can shrink back down a little bit. And then you'll see those little silvery scar tissue marks, and that's your stretch marks. It's because the collagen ripped. So let's see. And the collagen molecule is made from collagen protein. So there, you know that, because we talked about that before. Elastic is branching. So that tells you the difference there between collagen. So elastic is branching. It's wavy. It's made from what protein do you think? Bless you, made from elastin. All right, and this does allow for stretch and recoil. Thus, elastic allows for stretch and recoil. All right. So elastin molecules is made from the elastin protein. And then we have reticular. These fibers are also made from collagen. So that's why we say it's similar to collagen. But it's actually thinner and branching. And remember, collagen we said was unbranched. So it's kind of made from this, but a little different. So similar to collagen, but thinner and branching. And we use this to help support our soft organs, okay? So reticular means lacy or network-like. So if you want to think of like a hairnet, right? If people work in the food industry or that hairnet you're going to put on before you put a wig on or something. So you know how it's like all kind of crazy and net-like? That's what reticular fibers are kind of like. They are a net to help keep the soft tissue organ from, you know. All right, so they support the soft tissue organs. For example, lymph nodes, spleen, your liver, those all will have reticular fibers in it. So support for soft tissue organs such as lymph nodes, spleen, liver. So if you couldn't find reticular fibers before when you were looking online or somewhere else, you could now Dr. Google it and say, I want to see spleen, and then look for some reticular fibers, right? So that's what we want you guys to try to make those connections. Where would you find this? Why does it look different than something else? What are the similarities and what are the differences between the other CT, right? And that will help you understand how to figure that out. So now if we look at what are the cells that we see in CT. So I mentioned a fibroblast already, right? So fibroblasts are the most abundant in the CT proper. And proper means the typical CT, okay? So fibroblast is most abundant in CT proper, okay? So a chondroblast, where do you think chondro comes from? Cartilage, right? Chondro means cartilage. So look at these root words. It will help you try to figure out the answers. So chondroblast means you're making cartilage. Osteoblast means you're making bone. Osteo means bone. Hemocytoblast, what do you guys think that means? Heme, blood. Okay, other stuff too, but we're going to just stick with blood for now. I always abbreviate blood BLD, just so you know, but it's B. I know it has 2 O's in it. So you also find it in bone, but I just want you guys to focus on blood for that one. But look at the root word, heme, iron, right? You find that in blood. Cyto means cell. Blast means a functioning cell. So blast means it's like the building part. It's the younger cell. It's the more active cell. It's actively working and doing something, making something, okay? So all of those blasts means that they are making something actively. Versus when you see the term cyte, don't go with hemocytoblast. When you hear cyte, so if you heard chondrocyte or osteocyte, that is telling you that it's a cell that is less active. It's not doing so much. It's the more mature cell. It's like the one that's retiring, although retired people tend to be very busy, I'm just saying. But for cell purposes, it's the retired cell that's not doing much. It did all its work when it was younger. It's done. All right, so I'm going to put that over here. Blast, you want to think builder, younger. I'm not trying to be an ageist here. More active. All right, versus a blah, blah, blah cyte means that you're talking about, cyte means cell, but it also means it's usually going to be our less active cell. It's not doing very much, and it's more mature. And this will make sense as we look at some of the different types of CT in a moment. Jumping back over again, or think retired also. All right, so a mast cell. I don't know if any of you guys tried to find it because it wasn't listed in your lab manual, but your lab instructor probably said, hey guys, try to find a mast cell. Did anybody try to do that in lab? Good, good. So do try to look for one. Look at it online, Dr. Google, things like that. I don't remember if mast cell was in the, you might have to type it in to find it in Connect, in the APR, Anatomy and Physiology Revealed. But a mast cell is basically, it's a small mobile cell. It usually hangs out close to blood vessels. You're going to see it in areolar CT, which we're coming to in a second. It's full of granules, and the granules that are within it, when they get released, are heparin and histamine. And what do you guys know about histamine? Allergies, right? So when you have an allergy, whether it's local histamine, like something bites you or injects something into you and you have a local histamine reaction, what does it do? It swells up because it's trying to wall off what's going on there so it doesn't get to the rest of your body. It's bringing more white blood cells to the area. It's calling them over saying, come help, something happened here. I don't know what's going on. I need you to fix this before something bad happens. I don't know what, but something's going on. And then it's going to, so it walls it off. It starts putting a bunch of white blood cells. It makes it leaky so you can get your white blood cells from the blood vessels to that area. That's the heparin part and what histamine does also. And it's trying to prevent the rest of the body from getting affected. But sometimes the whole body gets affected, right? Maybe you got exposed to something that you're itchy all over. And, or maybe you have something so bad, histamine reaction so horrible, you might actually have an anaphylactic shock, which means you're like on death's door, okay? Because your whole body is like reacting to what just happened. And that's not good. You need help quick. We don't have time to go into that in too much detail. I'm just putting it out there a little bit. But let's see. So who would have more mast cells? Someone with allergies or someone without allergies? Someone with allergies. That makes perfect sense. Yes. So if you have allergies, what do you take? An antihistamine, because you're trying to block and prevent that histamine reaction. Because sometimes your body goes haywire, and it's not really like your life isn't in threat. You're not having an anaphylactic shock, but your body is going like, oh my gosh, everything's attacking me. Let's have a reaction. And you're going, what the heck is going on? I don't need to be itchy everywhere. All right, so let's see. So again, mast cells, look in areolar, loose connective tissue, areolar CT. That's where you're going to find your mast cells, okay? And it's also very vascular because we said it hangs out near blood vessels, right? Macrophages, number F there. Macrophages are phagocytic cells. We talked about phagocytosis before. So these macrophages are like the police officers or the neighborhood watch. They are patrolling. They are looking for something that doesn't belong there. And when they find that unwanted material, you don't belong here. You are a virus. You are a bacteria. You are something that got there, and I don't know what you are, but you don't belong here. You're not me. It will then remove it. It will phagocytose it and break it up and then get rid of the crap, literally. It does not belong there. This is not you crap, it's bad crap, right? So get rid of it. So that's what macrophages are doing. They're the patrollers. Let's look at types of CT. So that was general characteristics, right? And we talked about the protein fibers and the cells that you're going to find there. Now let's look at the specific various types. So the first one we want to talk about is connective tissue proper, okay? And it will either be loose CT or dense CT. Okay, those are our two types that we're going to talk about. In loose CT, you have three kinds. Do you guys see how a concept map would really help you guys separate these things out, make little lists, and review them so that you don't get on the exam and go, I don't remember a thing. They're all bunched up together. Make those concept maps or just make little lists, okay? So we have, of the loose CT, the three kinds is areolar, adipose, and reticular, okay? So on areolar, this is loose arrangement of fibers, because can you see it's kind of loosey-goosey in there, right? So loose arrangement of fibers. It's mostly ground substance, right? So I'm not seeing a cell here or here or here. This is all ground substance in there, okay? Mostly, that's why it's called loose, right? Loose, it's not tight, dense. So ground, there's an N in there somewhere. Let's rewrite that because that was crappy. Okay, here we go. Ground substance, right? With a few fibers and a few cells. So few fibers, few cells, okay? In this, the few cells that you might find in here, you might see some fibroblasts. You might see some adipocytes or adipose cells. We said mast cells might be here, right? And we'll also see some blood vessels, BVs or blood vessels. It's most widely distributed CT in the body, so this is the most common you're going to find, right? So I'll just put most common because I'm just saying you're going to see it in a lot of places. We use it for cushioning and also vascularity. Because we're talking about getting nutrients to places. Anytime you're talking about blood, you're talking about we're getting nutrients places. If I come back up to this picture up here, this was a picture of loose CT. Okay, can you see there's all that space? We have a couple of adipose cells in there. You have collagen and elastin fibers. You've got a macrophage over here. So just wanted to kind of point that out real quick. But that's who that guy was up there. All right, adipose is, fat is areolar with mostly fat cells in it. So you're not seeing a lot of other stuff in there. So it's areolar with, see what the line above it means with in shorthand, with mostly fat cells. Fat cells, the other name is adipocytes. So do you think adipocytes get bigger or smaller, or do you think you get more numbers of them or less numbers if you're gaining or losing weight? They get bigger or smaller. You don't change the number. So when they do like liposuction, they're removing the number of them, but it doesn't mean that you can't gain the weight back because the cells that are still there can just balloon up some more or shrink. Okay, so the whole purpose of the adipocytes is that they are storing fat for you. What do we store our fat cells, our fat substance as? Triglycerides. So I'm going to put TG. Triglycerides are the storage form of fat. We did talk about that for exam 1. And that's what you're going to find in an adipocyte because we store it there for energy for later. And when we need it, we can harvest that triglyceride out, break off the 3. Remember, it's a glycerol backbone with 3 fatty acids attached to it. We can break off a fatty acid chain, break up those covalent bonds in between, and get some energy out of it, right? We break a covalent bond, we get energy. That's the purpose of the triglyceride. So this is our storage for energy. Some of us store more than others. Yes, I do. And some of us don't store very well. Lucky them. So anyway, let's see what else do I want to tell you. So most of the fat cell is the pure droplet of neutral fat, meaning triglyceride. So most of fat cell is neutral fat, which we said was triglycerides. Adipose CT is very vascular, okay? Very vascular. So could you see if somebody doesn't know what they're doing with liposuction, they could kill you. You could bleed out, right? Adipose is a great insulator. Yes, it is. Yay for that. It's also a great shock absorber. So when I had lost a lot of weight, it really hurt when I fell on my bum. I didn't have anything to absorb the shock. All right. And like I said, energy storage site, right? Energy storage, because we're storing triglycerides. Energy storage site. Okay. So during the fixation process, meaning when they make the histology slide, the oil droplet, that neutral fat kind of gets sucked out or removed, and that's why these cells look empty inside, and their nucleus is pushed all the way to the side. So the adipocyte or fat cell's nucleus is not in the center of a cell. Most cells, the nucleus is centrally located, but not here. It's pushed off to the side because all that triglyceride that's being stored in there is what shoved it over to the side, essentially, okay? And let's see, and so what else do I want to tell you? Let's go on to reticular tissue. So this is a network, right? We said fibers, so network of fibers with fibroblasts, because fibroblasts make fibers, right? Fibroblasts. Okay. And has lots of white blood cells, so WBCs. So that's good. What did we say that reticular tissue does? It supports what? Soft organs. Like liver, spleen, lymph nodes. I'm not going to rewrite them. You guys know them. I wrote them above. All right, so that was all loose CT. The second category is dense CT. So dense makes you think it's not loose, it's not airy, it's dense, right? So that kind of makes sense. So dense CT, mostly densely packed protein fibers, okay? So dense CT looks very different than the loose CT. There are 3 types, but we only have 2 pictures of the dense CT. Okay, so we don't have a picture of elastic, but that's okay. If it's mostly collagen, it means that it's for high strength, right? Because we said collagen means for strength, not elasticity, but strength. If it's mostly made of elastic fibers or elastin protein, it means it's for stretchiness and recoil, right? So elastic is for our stretchiness. These have a poor blood supply for most dense CT because if it's dense, it's a little more difficult to get blood vessels through there. So that kind of makes sense. And an example of some dense regular CT would be like ligaments or tendons. Do you guys notice a lot of blood vessels in those areas? Right? That's why they also are more difficult to heal when you get injured. You need nutrients from blood vessels to heal. You don't have blood vessel, tissue may not heal, or it may take a long time to heal. So if we talk about dense regular, which is the first picture, can you see regular? Think uniform in the fiber direction, okay? So they'll also a lot of times call it white CT, okay? Because when it's fresh, a fresh specimen, it looks white. So also like think of like that silvery white if you like cut into like a chicken breast and you have that CT that you're trying to cut through or something like that. It's kind of dense, it's hard, it's white, it's no blood supply in it. I'll move on. Anyway, you guys are giving me that blank look. All right, so dense regular, we're talking about tendons. We're talking about ligaments. This is where you're going to find dense regular CT. It's tightly packed. It has parallel fibers, same direction, right? Parallel fibers. So collagen fibers look white when it's fresh. It would resist pull if it's in the direction of the fibers, right? Because if it's collagen, more likely also it's not going to stretch as much, but we can pull a little bit, right? You know, somebody pulls on your leg a little, you'll get a little stretch at the tendon area, but not a lot. Okay, so resists pull in longitudinal direction only. Okay, so for example, if we pull in this direction, right, that's good because it can have a little give or a slight stretch to it there. But what do you think happens if you pull this way on these fibers? If you pull too hard, it's going to tear. And not a lot of vascularity, so it's not going to heal well. Why do you think people have to go in and have surgery unlike their rotator cuff tendons, because they tore and they're not going to heal. And so the surgeon has to go in and try to make it heal for you. So this direction won't work, okay? But then if we take a look at, do I need to add any? Oh, and let me put vascularity is poor. Vascularity is poor. Again, think it's dense. You can't fit blood vessels through it. Tendons and ligaments don't have blood vessels running through them, so there you go. If we take a look at dense irregular, irregular means it's not lined up, it's not uniform, thus that look kind of looks like a piece of art, like swirly art. It's in all kinds of different directions, right? So these fibers are not parallel. Fibers not parallel. Okay. Found in areas where pull exists from many directions. So for example, skin, you could take your skin and move it all around in different directions, and it's got elasticity to it, right? And it should, if you're well hydrated, you know, go back to what it looked like, that recoil. So skin is a good example. Also, we have the fibrous capsule of some organs. So a little stretching is okay, right? Bone coverings, fascia that covers muscles. So this resists pull in many directions. So this way, this way, this way, this way, this way. It's going to resist that and allow you a little more stretch and be okay. So this is made with collagen, skin coverings over the various organs. That would include skeletal muscle, bone, cartilage, and we can even weave some blood vessels through it too. Can weave BVs through it. Because if it's going in all kinds of directions, you probably have a little more wiggle room versus tightly packed in one direction, right? So let's see. All right, elastic CT. This one is easy to memorize. E for easy, E for elastic. Okay, this is the least common CT because we only find it in a couple places. And the letter E is important here. Okay, so we will find elastic CT. This is mostly stretchy, consists mostly stretchy. Dense, regular, elastic fibers. Dense, regular, elastic fibers. Okay, so it's strong because of the collagen side of it, but because it's got the elastin in it, it's also stretchy with recoil. So we have very strong, but stretchy with recoil. So we're going to find this in areas of vocal cords, the aorta, so large blood vessels, and also an area called ligamentum nuchae. All right, so large BVs like the aorta. You're also going to find it with vocal cords and ligamentum nuchae. So nuchae, you have a nuchal line. When you guys are doing bones, did you find the nuchal line on the skull? There's a superior and an inferior nuchal line. That's where this ligament is attaching to. And the amount of tug that it's doing, the more obvious that ridge is, that line that you're seeing, the nuchal line. So now go back to your skulls from, was that last week you guys did skulls? This week is appendicular. So yeah, so go back and look at those skulls and find those nuchal lines. All right, so apparently we'll have to start with cartilage on the next one. And let me get your doodad up.